Woohoo! Welcome back. Today we're going to be talking about long division and synthetic division. Woo! And my friend, the happy little tree, is here to help us out. It's always good to have support, especially when you're doing long division. So I'm going to be doing long division of polynomials, and specifically today I just picked a random polynomial. 4x to the fifth minus 3x cubed plus 7x squared minus 5, and that polynomial is going to be divided by x plus 1. And this is a problem where you want to make sure you have a lot of paper. So make sure right at the outset you've got a bunch of sheets of paper to use, because this is not going to be fast. Synthetic division is going to be pretty quick. So, just as a reminder, pardon me, tree, the x plus 1 is called the divisor. The 4x to the fifth minus 3x cubed plus 7x squared minus 5 is what you're dividing. Most people just call it the what you're dividing thing, but it's the dividend, which is always an interesting word. Now, as I'm writing it out, everybody's got a different style, but I would recommend that you include zeros. So in other words, because it goes from 4x to the fifth to negative 3x cubed, I would include the x to the fourth. I personally find it useful. Other people get really annoyed, so you do you. However that works, I'm going to include my zeros. So 0x to the fourth. Then I've got minus 3x cubed, then plus 7x squared. Then I notice, I did another skip. There's no x, so I'm going to put in plus 0x, and then minus 5. This is going to be a long one. Woohoo! So hopefully you've got something, good to snack on, and some, make sure you stay hydrated. You can always pause the video and come back later. Okay, so I have a particular way I do long division, and I'm sure you can find lots of other people doing it lots of different ways. The way that I do it is I ask myself, what times x gives me 4x to the fifth? The other way to do it is to say 4x to the fifth divided by x, and both work. So I'm thinking, what times x gets me to 4x to the fifth? And I need to stick in a 4, so I'm going to need a 4, and I need 4 more x's, right? So I'm going to have 4x to the fourth. And that's because I'm looking at just this and just this, the leading term of the divisor and the leading term of the dividend. Woohoo! So I also like to try to keep my columns really lined up. You don't have to. The way that polynomial division works, you can be a little bit, less precise about your quotient, but I like to line them up, so I'm going to do that. So once I figure out what I'm going to put up here, then I multiply both terms. So 4x to the fourth times x is 4x to the fifth, and then 4x to the fourth times 1 is 4x to the fourth. Now here's where my method differs from some people, and it just depends on how you were taught to do this. I was taught, and I'll use my red pen to make it easier to see, I was taught to change the sign. So this becomes a negative, this is a positive, so it becomes a negative, and then you add. Adding the opposite is the same thing as subtracting. So if you learn to subtract, you go for it. You do that. So 4x to the fifth minus 4x to the fifth is 0x to the fifth. Again, if this bugs you, just leave it blank. That's fine. 0x to the fourth plus a negative 4x to the fourth is a negative 4x to the fourth. Having done that, I cleared my x to the fifths, so I'm going to bring another term in, my minus 3x cubed, and I'm going to do the same process. We just do this over and 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 over. Okay, so I'm going to look at my negative 4 x to the fourth and my x, And now this becomes the new leading term because the 0x to the 5th is canceled. And what times x gives me negative 4x to the 4th? I need a negative 4. And I'm going to need, I've got 1x, I need 4 x's, so I'm going to bring in another 3 x's, x cubed. And then just like before, I take this new term, multiply it times x. That's negative 4x to the 4th. And then I also multiply it times 1. Negative 4x cubed times 1 is negative 4x cubed. And remember, with my method, I'm going to go ahead and with the red pen, I'm going to change the signs. Change the signs. And then add. And that's what I did up here as well. Okay, so I got to change this sign and I got to change this sign. And then I'm going to add. Negative 4x to the 4th plus 4x to the 4th is 0x to the 4th. And again, you can leave that blank if you'd like. And then negative 3x cubed plus 4x cubed is x cubed. Just one of them. And then I bring down the next term, 7x squared. Okay. Then I look at the first term here. That's the leading term because this is 0 now, so it doesn't count. We don't look at that anymore. We dealt with the x to the 4ths, x cubed. And then we say, oh, this one's going to be nice. Look how nice that is. I've got an x. I want x cubed. So the coefficient is 1. Don't have to change that. But I need 2 more x's. So I'm going to have plus x squared. And again, there's my x squared column. See how I'm keeping them all lined up? It's kind of nice. Makes me happy. If it doesn't make you happy, don't do it. Okay, x squared times x is x cubed. X squared times 1 is x squared. I'm going to bring the red pen. I'm going to change the sign. Change. And then I'm going to add. X cubed plus a negative x cubed, 0x cubes. 7x squared minus x squared is 6x squared. Am I worried? Well, suddenly that escalated quickly, so I'm not sure where this is going. That's a lie. I did work out this one, so we're not going to end up with like 142,000, I promise. So it's a bit of a lie. But as I'm working through it the first time, I don't know where it's going to go, and I am a little worried because when the numbers start to get bigger, sometimes they just get bigger and bigger. So deep breath, keep a calculator handy in case you're nervous, and, make sure you've got support, a happy little tree saying, you can do it. Okay, then I'm going to bring down, and I know it's going to feel a little bit weird, but I'm going to bring down nothing. But that's going to be my placeholder, so I don't forget. And that helps me. Okay, the x cubes are done. Now I've got 6x squared. What times x gives me 6x squared? I need to bring in a 6, and I need to bring in another x. So I'm going to bring in a 6x. So now I'm going to take the 6x times x. That's 6x squared. 6x times 1. That's 6x. I'm going to bring in my red pen, change those signs, and add. 6x squared plus a negative 6x squared is 0x squared. Woohoo! 0x plus a negative 6x is a negative 6x. And I'm very excited because this is the last thing I'm going to bring. Right? I've got a minus 6x minus 5. So then I look at the negative 6x, I look at the x, and I think, what do I need to bring in? Pardon me. I'm going to take this x, and I'm going to say I have to multiply it times negative 6. So I'm going to put a negative 6 up here. Negative 6 times x is a negative 6x. Negative 6 times 1 is a negative 6. And again, red pen comes in, change those signs. Every step, I'm going to change the signs, and then I'm going to add. Or if you don't like that, you're going to subtract. So either change the signs and add, or just subtract. I get 0x. That's very exciting. It all cancels out. And then I'm like, oh, so close. -5 plus 6 is 1. Now at this point, the degree of what I'm working with, this is just a number 1, the degree is 0. And the divisor up here is an x plus 1. That's a degree 1. So the divisor is too big. We can't make it go into 1. So we're done. How would you also know that? Well, you'd also notice that because we've run out of things to bring down. We don't do decimals in polynomials. There's no decimal polynomial form. So once you run out of terms to bring down, you're done. That's it. We've got a remainder of 1. So our answer right here is that 4x to the 5th, and I know you can't see this, minus 3x cubed plus 7x squared minus 5 divided by x plus 1, I'm writing it all out and I'll show it to you in just a second, is 4x to the 4th minus 4x cubed plus x squared plus 6x minus 6 minus 6, sorry, I got excited about the remainder, minus 6, and then, oh no, oh no, oh no. Okay, it's fine. Don't worry, don't worry. We got it. We're good. Look over there. Oh my goodness. Is that a rainbow? So, our answer looks like that. Except for the little scratchy R. I don't know who did that. Heads will roll. Now, there are 2 ways to write your answer. You can write it with a remainder, or remember, you can take the remainder and write it over the divisor. So that x plus 1 that's there, this one goes right there underneath the remainder. This one right there is this one right there. I'm not sure that was helpful. And then I should also point out that this part right here, if I've got any space left, is the quotient. Little tiny quotient. And then this is the remainder. Woohoo. So this is long division. It's long. It actually took less space than I thought. Nicely done. Pat ourselves on the back. And next thing we're going to do is we're going to go ahead and do the same problem, but now with synthetic division. So, what are the rules for synthetic division? Well, it depends on your perspective. In my class, generally, I say, whatever you're going to be doing, if you've got a polynomial, as long as you're dividing by x minus c. So in other words, x has a coefficient of 1, and then there's a number, and that's it. And that's what we work on. Now, are there ways to do synthetic division with a coefficient that's 2 or 5? Yes. Are there ways to do synthetic division if you've got x squared? We could probably have an argument about that, but I would generally say, synthetic division is best used when you're dividing by x or x and a number. And that's it. So how do you do it? Well, in this case, if we've got 4x to the 5th minus 3x cubed plus 7x squared minus 5 divided by x plus 1, we set it up much like how we did it with the long division. We take this and we include all the zeros. So what we're going to do is we're going to pull out all the x's and just look at the coefficients. So I'm going to write 4 because it's 4x to the 5th. And then I'm going to write 0 because there are no x to the 4ths. Then I'm going to write -3 for the x cubed. So this is x to the 5th. This is x to the 4th. This is x cubed. Then next would be x squared. So that's going to be 7. And then x's, there aren't any x's, so 0. And then the 1's is -5. Now, everybody's got a different way to write this. I learned this with a little box over here, and I know that there are people who learned a big box, and there's other boxes, and I'm sure there are triangle people and circle people. And you know what? Honestly, as long as you're following the pattern, it does not matter where you put your lines. I know. We'll see. There'll probably be hate comments about that. What's really important, though, is with synthetic division, we're trying to simplify things a lot. And so we're going to take out a bunch of the steps. In order to make the division work, we're going to combine the change the signs and add. And the way we're going to do that is we're going to say right off the bat with this one, if you've got a x plus 1, I'm going to change the sign. I'm going to put a -1 there. So this -1, this is x minus a -1, if that makes sense. So we're going to use the -1 there. So if it's x plus 2, it'd be -2. If it were x minus 3, we'd put a +3. So we're going to change the sign. Make sure this is a different sign. And that's going to allow us to make sure that the division works. And again, everybody's got a different way to draw it. This is the way I was taught. I really like it, so this is the way I teach it. Right off the bat, whatever number came first sticks around. That's it. You get to keep the 4. Now we get into the pattern. And the pattern's pretty cool. Once you learn the pattern, it goes really fast. So you take the 4 that came down here, and you multiply times -1. 4 times -1 is -4. And then as you come down, you add, just like with the standard division. So with standard division, remember what the steps were. The steps were change the signs, then add. We changed the sign right at the beginning, so we just do it once, it's done. And then we just keep adding. So 0 plus -4, -4. Then we take -4 times -1, and that's going to be -4 times -1 is +4. That goes here. So we have this this pattern where you come up here, and then you go down there, and then you add, and then you come up here, and then you come over here for the next one, and then let's add. -3 plus 4 is 1. Then we do 1 times -1, so we look up there. 1 times -1 is -1, and then we add. 7 plus a -1 is 6. 6 times -1, -6. 0 plus -6, -6. -6 times -1 is 6. -5 plus 6 is 1. That's it. So here's why is synthetic division worth learning. This is long division. It is long, right? No lie. Here's synthetic division. Same problem. Just bing, bang, boom. You're done. Now, how do you read this? So you have to start from the right. Whatever number is here is the remainder. If we're lucky, that's 0, and then it goes in perfectly, but it's not. It's a remainder of 1. We know that from this problem. And then we start counting from here. These are going to be the 1s. These are going to be the x's. X squared, x cubed, and x to the 4th. And people are going to ask me, wait a minute, why didn't it go to x to the 5th? And the answer is, we had a 5th degree polynomial. We divide by 1st degree. So we're pulling one x out. So the max is now an x to the 4th. So it got smaller by 1. It kind of makes sense. 4x to the 4th minus 4x cubed plus 1x squared plus 6x minus 6 with a remainder of 1. And what's so cool about that is that's exactly the same answer we got before. So we got the same answer 2 different ways. Bam. Our happy little tree is so proud of us. Happy tree is so happy. So let me go ahead and pull this back up so you can screenshot this lovely little thing. There's our synthetic division. I will make the notes available to you too. If you want to see another one, let me know. Dance party with the happy little tree. You guys are awesome. You're amazing. You made it through 20 minutes of division of polynomials, which is, 20 minutes you're not going to get back. But you've built character, you've learned something, and I feel like we've all changed as people. Really, I feel like we've been on a journey in the last 20 minutes and 21 seconds, and I really feel different now. I feel closer. I feel I understand the world better, and maybe I want a snack. I'm hungrier, so I have changed. Hopefully, you've changed, and just know that you're awesome and amazing, and math on. Woohoo!